Hello guys, welcome back to my channel. So today I'm going to build yet again a VPN site to site, LAN to LAN. That which means we're going to have traffic going from one site, that's PC1, to the other side, which is PC2. Okay, it's going to go through the edge routers, router 1 and router 2, passing through the ISP. Okay. So the last time we built a GRE over IP VPN just like this one, but it wasn't protected. So right now we're going to do this with IPSEC tunnel profiles, and the configuration, like the global connectivity configuration between the routers is not done yet. So that's what I'm going to do right now, and I'll be back. All right, so I went ahead and powered on all the devices, and I made sure the global connectivity between R1 to ISP and R2 to ISP and also R1 to R2 globally is available, because that's a precondition for creating for configuring the VPN and any VPN in general. So let's just double check and be sure of this. So if I open my command prompt, I go to PC1 to router 1. From router 1 I can ping, by the way, the IP scheme that I have here is on router 1. On the internet facing port of router 1 I have 64.64.64.1, no, .2 here. Okay, and on the router 2, the internet facing port, I have 65.65.65.2. okay, so that one is going to be on the ISPN. Okay, so if I from .2 I should be able to ping .1. From .2 here I should also be able to ping .1. Okay, so let's go to R1 and let's ping 64.64.64.1, which is supposed to be our ISP. Okay, responding, and let's ping R2, which is the other side, which is 65.65.65.2. okay, also responding. Now if you go to a PC on the LAN side, okay, if you go to PC1, which is supposed to be this PC should be able to ping only this router. Okay, whether this interface or that other interface doesn't matter, but it shouldn't be able to ping anywhere beyond that. So let's go to this PC1. I already did a ping, but I just want to show you. So from PC1 I should be able to ping the gateway. First of all, ping because I configured PC1 with IP address of 192.168.10.10. okay, that's the IP I gave for this PC1 here. So from this PC, let's do ping to the gateway, which is 192.168.10.1. okay, ping is responding. Now if I want to ping the internet facing port of R1, which is, if I'm pinging 64.64.64.2, that ping should also respond. That ping should also respond because I'm trying to ping from this PC. Okay, from this PC I'm trying to ping this other interface here. Okay, if you can see what I'm doing. So from here I'm trying to be able to ping what's going on. Okay, right, so I'm trying to source a ping from this PC to this interface here. That's working, but I should not be able to ping anywhere beyond. Okay, anywhere beyond should not work, whether it's through the tunnel or directly on the other side, it should not work. Okay, so all right, so let's do a ping. I'm going to ping the internet facing port. I'm going to do the same thing for the for PC2, but for now let's just ping the ISP. Try to ping the ISP from PC1. ISP is .1. okay, that ping should fail. Okay, that ping is failing. So if I do the same test for PC2, which I did already, I cannot ping the ISP from PC2. Okay, and if I'm pinging the internet facing port of R2, that should work. Okay, that works. Okay, so we're set and done. We're set and ready to do our VPN configuration. So now we are ready to start our VPN configuration. First, we're going to do on R1, and then we're going to do on R2, and then after that, we'll do the testing. So we're going to start our configuration on R1. So the first thing we want to do is to configure the IPFIX one. So configure terminal. We'll create an crypto EtherCamp policy. Policy 10. Provide an encryption. Then we set the hash. Set the hash MD5. Then we're going to set the authentication is pre-shared. The VPN group is group 2. Group 2. Actually, we have several, but I'm going to choose group 2. We exit out of there. And then we provide a key. Okay, so we're going to provide a key. If I see something missing there. Okay, key. Okay. Key 0 means it's going to be unencrypted. Let's use let's go 1, 2, 3 for the key, and then we provide the address of the remote end or the peer end, which is going to be 65.65.65.2. Okay. Now we're going to configure the transform set. Crypto IPSEC transform set. We call it my set. Then we provide the payload ESP 3 days. It's going to be encryption is going to be 3 days, and the payload for the hash is going to be MD5. Now we're going to set the mode to transport. Actually, there are two modes. They're going to be transport mode and tunnel mode. You're going to choose the mode transport, usually the best for side-to-side VPN. Okay, for side-to-side VPN, but for multi-point VPN, tunnel mode is going to be better. Okay, so for side-to-side VPN, it's going to select the mode transport. We exit out of there. Then we provide a crypto. Now this time around, we're going to provide, instead of crypto maps, we're going to provide a crypto profile. So it's going to be crypto IPSEC profile. We'll provide a profile name. We'll set the transform set to my set. Then we exit out of there. Next, we're going to configure the tunnel, because now we configure the crypto map, but we haven't configured we have configured the crypto tunnel. Okay, we haven't configured the tunnel yet. So now we're going to configure the tunnels. Interface tunnel 0. Call it tunnel 0. We're going to give an IP address to the tunnel. Let's give it an IP address of 10.0.0.1 255.0. Then we're going to inject OSPF into that tunnel. OSPF instance 100, area 100. Create a tunnel source. The tunnel source is going to be the internet-facing IP of R1. Okay. Either we give the IP or we can give the interface. We can just say serial 0/0 is the tunnel source. Okay, 0/0. Okay, and tunnel destination. Tunnel destination is the IP address of the internet-facing port of R2. So it's going to be 65.2. That's the destination. And now we're going to have to apply the tunnel profile that we just created. Okay, we created a tunnel profile. Now we have to apply that tunnel profile on the tunnel itself. Okay, so tunnel protection, IPSEC profile, and then we'll provide a tunnel name. Tunnel profile. Hopefully the name is correct. So the configuration is done on R1, so we have to do the same configuration on R2, but it's going to be a mirror image of the configuration that we just did here. And as we just finished on R1, you see ISACAM turned on. So yeah, I think. So what I'm going to do, I'm just going to just mirror configure the same thing on the other side, R2. And so what we did is we created IPv phase 1, CryptoMart, we created the policy 10, then encryption 3 des, hash MD5. We said it's going to use pre-shared key. And this is the pre-shared key Cisco 123. And it's going to it's going to authenticate with the peer end, which is going to, this time it's going to be R1, which is 64.64.64.2. And then we created a transform set, call it my set. Okay, with the encryption 3 des with hashed MD5. We said the mode is going to be transport because it's beta mode for side-to-side VPN. And then we created a tunnel profile, okay, with the name tunnel profile that we're going to apply on the tunnel. Okay, we gave then we also apply on that tunnel profile the transform set my set. So on the for R2 the configuration is all set. Okay, I just made some reverse IP address notations here, like for the tunnel interface for R2 it's going to be 10.0.0.2 instead of .1. Okay, so I'm just going to copy and paste in R2. I don't type very quickly, so I'm just going to copy and paste on R2. I go to R2, configure terminal. Okay, I'm going to create the transform set. Okay. Anyways, I'm using GNS3, so sometimes it doesn't. Hopefully I didn't mess up the configuration. So now we're going to create the tunnel profile. Okay, exit. Now we're going to create the tunnel itself. We'll apply the crypto. Okay, copy. All right, so we've completed the configuration on R2, and if we do show crypto user SR, okay, we'll see a tunnel came up. So there's now the tunnel between R2 and R1 is up, but there's no traffic passing through it. Okay, we're gonna check that. If we do try to do a ping, let's say we're pinging from PC2 to PC1. Let's do a ping. Let's ping from PC2. If we're pinging PC1, it's going to be 192.168.10. Let's ping the PC itself. We could also ping the fast ethernet 0. The PC is .10, so let's try the ping. Okay, ping is not working. The reason ping is not working is because if we come in here, we do show IP route. Okay, so we should not be seeing that 192.168.10.10.0 network here. We shouldn't be seeing. The reason is because when we configure the tunnel interface, if I do show run interface tunnel 0, we configured the tunnel interface. We injected OSPF instance 100 area 100 into the tunnel interface, but we don't see OSPF routes. Okay, we don't see those OSPF routes. The reason is because we haven't yet injected OSPF into our fast ethernet zeros of the R1 or R2. Okay, so if I check show run interface fast ethernet 0/0, which is the LAN facing site, there's no OSPF here, so that we need to inject OSPF into this interface with this command here. Okay, we need to inject OSPF, and we have to do the same thing for on the R1 side. So I went ahead, I added OSPF, I injected OSPF into the fast ethernet 0 of R1 and R2. Okay, so in that way we should be able to see if we do show IP route. If we do show IP route, we should be seeing OSPF route for 20.0 if we're looking from R1, so we're doing right now. Okay, we're checking from R1, we should be seeing now the OSPF route for 20.0, which means if we do a ping from R1, from PC1 to PC2, that ping should work. Okay, if I just do a ping 192.168.20.10, okay, ping is responding. So there's full connectivity between. So now from PC1, I'm actually able to ping PC2, and the good thing is traffic is going through the ISP, but it's actually encrypted, unlike the last time when we had GRE over IP tunnel where traffic was going through our tunnel, but it was not encrypted, which means somebody could actually intercept that traffic in the middle, and so today we have a full working VPN that's with encrypted traffic. So let's do further troubleshooting on this. Okay, so from R1, if we do show crypto user can as well, okay, we see the tunnel is up there. So let's do show crypto IPSEC security association. Okay, so you can see the interesting traffic Okay, the tunnel is being kept alive by the interesting traffic generated from 64.64.64.2 to 64.64.65 to 65.65.65.2. Okay, so and we can also see that the Security Association is using transport is using transport mode. Okay, and one more thing that we can notice is the encrypted and decrypted traffic. If we're going to check this several times, you're going to see the encrypted and decrypted traffic will keep incrementing, and the reason is that we have our tunnel constantly being up due to traffic that's generated by this by our proxy ACL. So if we do show, if I just do show crypto is IPSEC SA, so now it's 66. Okay, a while ago it was 53, now it's 66. So the encrypted and decrypted traffic packets keep increasing. Now if I do show interface tunnel 0, so what we notice here is we can see that the tunnel protection is IPSEC. Okay, we can see that it's running in transport mode. What is that? Running in transport mode, and the tunnel protocol is GRE over IP. Okay. Yeah, so the encapsulation is tunnel, and the tunnel protocol is in transport mode and GRE over IP. Okay, with encrypted traffic. So that's basically it for today. Here's my diagram again. Alright, so that's basically it for today. So next time we're going to see site-to-site, LAN-to-LAN VPN. Okay, it's going to be GRE over IP with virtual tunnel interface. Okay, so that's the next thing we're going to watch. We're going to see for next video. And thanks a lot for watching, and talk to you next time.